Let's begin. I'm Srinaja. I'm the GitHub campus expert. And today we will be talking about NumPy, and we'll be looking at a little bit of the execution part of NumPy. We'll see what operations NumPy offers and what functions and methods it has. So let's begin. So first, what is NumPy? Every one of you would have heard about what NumPy is, but if you don't know what it is, so it's an open source library for scientific computing. What do I mean by scientific computing? It means that analysis of mathematical models can be done in using NumPy. So NumPy is a Python library, and it has built-in functions for data manipulation. So this is what NumPy is. NumPy offers a very powerful data structure called the array. I'm sure all of you know what an array is. So an array is a list of values that have the similar data type. So it's the same even in NumPy. So in NumPy, an array is a grid of values, all of the same data type. In general arrays, there is no negative indexing, correct? Same is carried on to NumPy arrays. In NumPy arrays, a negative indexing is not allowed. Indexing starts from 0 and ends at some n, and n cannot be negative. And so this is what NumPy is. So you may ask, we have lists, correct? Why do we have to use NumPy when we have simple Python lists? Python lists are simple to declare, right? Simple to initialize. You just take a variable name and assign it to some empty list or a list of values, correct? So why do we have to use NumPy arrays? So the thing is, NumPy arrays are faster and more compact than Python lists. This is because arrays are homogeneous collections of data. So what I mean by homogeneous collection, there are similar data types in a NumPy array. If you take integer, there's only integers in array. If it is strings, it's only strings in arrays. But in lists, you can have integer, strings, anything you want. A list in a list, that is also possible. So this is why Python lists are faster. And not only this, NumPy arrays are faster than Python lists. One other reason is that Python lists store data in a non-contiguous memory location. You know what non-contiguous memory allocations mean. So I'm not going to go deep into that. The last reason is that NumPy breaks down one data that you have into a lot of structures, into a lot of multiple smaller structures. And these structures are processed parallelly. They're processed separately and parallelly. So that is why NumPy arrays are faster and more compact than Python lists. One last reason is that NumPy arrays, they support a lot of mathematical functions, a lot of powerful mathematical functions. Sure, lists, they have a lot of functions such as max, min, sum, count, and stuff like that. But NumPy arrays, they offer far more powerful mathematical functions. You'll see soon enough. So this is why we use NumPy arrays. One other application, we'll talk about the applications of NumPy array in detail later on, but for now, all you need to know is that we can perform probability and statistics using NumPy. And then in image processing, I will talk about this later, but in image processing, you store an image in a NumPy array. Not only that, you can also explore any data set, apply mathematical functions to the data present in your data set using NumPy. So this is a brief introduction about what NumPy is, what applications it has, and why we have to use NumPy arrays. So yeah, this is it. We'll begin with execution. If you want, you can do it along with me. If not, then you can just go through the recording later on, and then you can do it on your own. To execute Python commands, there is this online platform called Colab. I'm sure everybody knows about Colab. If you do not have any Python interface or any IDE in your laptop, you can use this. Link is in the chat. I will be using my Jupyter notebook because my internet is not that great and I do not want to get logged off. So yeah, let's begin with execution. This is a Jupyter notebook if you don't know what it is. So these are called cells, and you can execute Python commands. Not only Python commands, yeah, you know soon. Okay, so let me know when you're ready, if you're doing it along with me or if you are if you want to do it later. So yeah, NumPy, if you want to install NumPy in your laptop, and if you have not installed already, then you can use pip install NumPy or conda install NumPy if you have Anaconda with you. If not, then Collab does not require any installations. Just type, just go ahead with your commands. So since I already installed my install NumPy on my laptop, I'm not going to go ahead with it. I'm just going to import NumPy, saying import NumPy as npm. So the thing is, you can use anything here, but np is very common and it's very easy to access. So yeah, import NumPy as np. So let's say you have downloaded, installed NumPy in your laptop, and you want to see the version of the NumPy packages you're using right now. So for that, you use np dot underscore version underscore, and then hit shift enter, and then you will find the version of NumPy that you're using right now. So this is the okay, so you understand how I'm executing, correct? So if you have chat, and we'll have the Q&A session later on. So this is how you import NumPy, and as I mentioned before, you have Python lists, right? So can you hear me properly?
Yeah, it's fine.
Awesome. Okay, cool. So as I mentioned before, you have Python lists. Why don't you use Python lists? Because they support various data types, and it's not as fast as NumPy is. So we will start converting a Python list into a NumPy array. So for that, I'm using I'm creating a list first. I'm creating a list of which has 4 elements, 1, 2, 3, and 4. And now I want to convert this list into an array, into a NumPy array. So for that, I have a method called nt.array. Pass in the list that you created, and then execute it. So now you see that this is a NumPy array. This is a NumPy array. If you want to check, then you type list. So sorry, I'm assigning this to a variable called arr1, and then let me display arr1. So let me show you the type of it. It's numpy.nd array. So this is array in NumPy. So not only can you convert a list into an array, also convert a list of lists. Let's say matrix into an array. Let me create a matrix. And I'm passing values in it. And now I want to convert this into an array. So I'm going to assign this into to another variable np to convert this matrix into a NumPy array. I'm going to use the same method as I used before, np.array, and I'm going to pass in the list. Sorry. And now if I display this is an array. It's a NumPy array. So not only lists, you can also convert a tuple or a dictionary into a NumPy array. So let's say let's say this is my dictionary. I'll say 1. And now I want to convert this into an array. I'll say array 3 is equal to np.array of like 1. And if I display this is an array, the type is object. So this is how you convert any Python data structure into an array. I'll send resources later on. You can go through it. There's a description on how you can convert and what happens on the back end. So you can go through that. Another very, very important method that you have in NumPy is range. So it's called a range. have you heard of, if you have heard of the method called range in function, this is in Python, this is the same, range is the same as range. So to convert, to generate a list of evenly spaced values within a given interval, you use np.arange and pass in values. Let's say I want to convert, I want to print a list of integers from 0 to 10. So from 0 is included and 10 is excluded. So this is how it works. As a range offers start, step, stop and step, even a range offers start, stop and step. So np.arange, let's say I want to print let's say I want to print odd numbers between 1 and 11. Okay, so or 0 and 10. So I'm sorry, 1 and 10, let's say. So I give step is 2 and I get odd numbers from 1 to 10 excluding 10. So let's say I want to print even numbers from 0 to 10, between 0 to 10. 0 and 10. I give this and I get all even integers present between 0 and 10. So this is arange. Arange is going to be used extensively when you're doing EDA. If you don't know what EDA is, it's exploratory data analysis. And yeah, it's used extensively in that everywhere you go, you use arange, you give a list of numbers, and then you say you want to plot them against these values that you have. You use arange and linspace. I'll talk about linspace in a few minutes. So okay, next method that I have for you is it's called zeros. So zeros. As I mentioned when I was talking about NumPy, NumPy arrays are used to store images for image processing and computer vision. So when you say you store images in a NumPy array, what you mean is that you store, let's say you have a number 1 and that is an image and you're storing it in a NumPy array. So when the number 1 is displayed in black and the background is white. So whatever, wherever you have the black outline, there you will have the number 1, and the background it'll have zeros. So for that you use this to initialize something that stores an image. You use this. It's called np. It's called zeros, and to create a list or an array. I'm sorry, to create an array of 10 zeros, you say np dot zeros of 10. So you get a list of you get an array of 10 zeros. Let's say you want to make a matrix, to create a matrix of 2 rows and 5 columns. So what can you do? np dot zeros of 2, 5. So the reason I'm passing this in a tuple is because I want the method to run that I want it in a matrix form. So 2 rows and 5 columns, you have an array. So this is zeros. Similarly, you have ones. So it's the same. Just type np dot ones. Let's say you want to display 10 ones. So you pass in 10 as the parameter, and then np dot ones. Let's say you want to display a matrix of 3 rows of ones and 4 columns of ones. You do this and you got it. So this is what zeros and ones are. These are also used extensively in image processing. So in matrices, you would have come across an identity matrix, right? So to create an array of identity matrix, you use np.i, EI, and then pass in the index 3. So this is the size of the matrix, 3 by 3. So 3 rows and 3 columns. And an identity matrix is always a square matrix. So yep. So that is it. You get ones in the diagonal row, and this is how you create a identity matrix. So if you want more rows and more columns, just type whatever you want, and that's it. So next is linspace. So as I mentioned before, to create an array of evenly spaced integers over a specific interval, we use linspace. So where can this be used? When I said that when you want to plot your data points in a graph against some other data points, those other data points are unknown to you, but you want it to be put in a graphical form. So what you can do is you can create an array of some evenly spaced integers, and for that you use linspace. So for that, the method is np.linspace. You pass in, let's say I want five integers from 0 to 10. So you get evenly spaced integers. So 0, 2.5, 5, 7.5, and 10. So these are evenly spaced, and from 0 to 1, and these are 5 in number. If I want, let's say I want from 0 to 100, I want 5 integers, let's say 6 integers. I get these. So these are 6 in number, and these are evenly spaced. So this is how you use linspace. It's not only from 0. You can start it from wherever you want. Let's say 4 to 7. I want 10 integers. You get this. So this is linspace, and okay. These are the main methods that you use in NumPy. These are commonly used. There is another package in, there's another module in NumPy called the random module. It has a lot of functions. So it's even present in the normal Python. It's even present as a normal Python module, but in NumPy, it has a lot of other useful functions as well. So okay, so let's say I want to generate 10 random integers. I say np.random.rand. I want 10. So I am passing 10, and I got like 10 integers, 10 floating point variable values from 0 to 1. 1 is exclusive. So this is called, okay, when you get values from 0 to 1, 1 exclusive and 0 included, that is called a uniform distribution. So rand creates an array of the given shape. Shape is 10 here, and it populates it with random samples. Random samples as in these you got here. These are randomly generated. So what I mean when I say randomly generated, so okay, random is not different. It is something that you cannot predict logically. So when I say random, it does not mean that for one system I get one variable, and for another one value, and for another system I get another value. It's not that. It means random is something that cannot be predicted logically. So it is very, the name suggests it's very random. So that is okay. This is a 1D array, right? So if I want to generate a lot of let's say I want to generate 4 cross 4 matrix of random values. I say np.random.rand and 4 by 4. And if I want to create an array of 3 by 5 random values, then I pass in 3, 5. This does not need to be passed in a tuple. This can just be passed directly. So this is random.rand. So just to recall, rand creates an array and populates it with random samples from the uniform distribution. What is a uniform distribution? 0 included, 1 excluded. So it's generally written like this: 0 and 1. If you are a mathematics student, then you will understand what this is. So this is uniform distribution. And next, we have another function method called rand_n. So rand_n, it returns an array from the standard normal distribution. So okay, let me show you. The function is the method is rand_n, let's say I want 4 values. Let's say I want 5 values. So I get all of this. So it's standard normal distribution. It's not restricted to 0 and 1. It can be anything. So that is rand n. By default, when you just type np.random.randn without passing any parameters, it returns 1 value. So the default value for any random function is 1. The number of values you get is 1. Let's say you want to create a matrix of 2 by 3 size and of random values. I just pass 2 by 3 and you get a matrix of 2 rows and 3 columns. So this is rand n. There is another thing called rand int. It returns random integers over a given range. So let's say I want to print random integers from 1 to 10. Some random integers 1 to 10. Default, you'll get 1. Since I have not mentioned any number of random values that I want, you get only 1. But if I want like, let's say I want 2 integers from 1 and 10, let's say I want 2 integers of those. So I pass in 2 and then I get an array with 2 random integers from 1 and 10. So this is np.random.randint. If you want like, okay, let's say not only 2, let's say you want like 100 values. np.random.randint. From 1 to 200, 300, let's say I want 100 integers. You get an array of 100 integers which are randomly selected from 1 and 300. Okay, so this is random. There are a lot other methods that you have in random, but these are the main ones that you use. In the resource that I'll be sending you, you will find a lot more methods, so you can go through those. But for now, these are the basic methods that you use on a daily basis, on a very regular basis. So if you're doing EDA, these are the methods that you use. Next is, let's say you have an, I'm going to initialize another array from 1 to 11. I want, okay, 1 to 11, I get this, right? So now I want to reshape it. This is a 1D array, right? So let's say I want this to be in a 2D format. I do arr1 dot reshape, and I pass in a tuple the number of columns and rows I want. Since these are 10 values, I can do 5, 2, and I will get 5 rows and 2 columns. This 1D array has been reshaped to a 2D array of 5 rows and 2 columns. So let's take another array. Let's say I have 100. Let's have 25 values. So from 1 to 100, okay, so from 1 to 26, let's say, and I want to reshape this. This is the array you have. I want to reshape this into a square matrix. So I say arr2 dot reshape. I pass in 5, 5. 5, is a square matrix and it has 25 values. So this is how you do it. Reshape is also used a lot. You will know when you're doing when you have an actual data set and you're exploring the data set, you're trying to derive insights from it, you will know how this can be used. So okay, let's take a random array. Let's say I want I'll initialize it to another variable np.random.randint. Let's say I want like 10 values from 1 to 100. We can look at the array here. And now I want to find the maximum of, let's take 70 values you have. So going through the entire array and searching for the maximum element, maximum value of the list of the array is tedious. Sometimes it's not only 70, you have like thousands of values in your array, and you cannot possibly find the maximum in that array by yourself. So what you do is you say arr3 dot max. The maximum number is 99, and let's say you want to find the minimum of it, minimum of the array, minimum of all the elements present in the array. You say arr3 dot min. So the functions are the methods are max and min. Now let's say I want to find the index of these this max element and the index of this min element. For that, there is another method called argmin and argmax. So the number one, the integer 1 is present in the 56th position. That's what it says. And let's say I want to find the max of it, the index where max is. So I'm gonna type ar3.argmax, and then you will find that 56 is in the 30th position. I can find it here. But okay, so yeah, argmax and argmin return the indexes of the maximum element and the minimum element respectively. So this is min and max and stuff. So okay, let's take array 3. This is your array 3. What is shape of this? So you pass in it's an attribute. Its attribute to an array is shape is an attribute to an array. So attribute does not have these parentheses. So that is how you differentiate between an attribute and a function or a method. So yeah, so since I put 70 values here, I took randomly, I took 70 values randomly. The it has 70 numbers, right? 70 integers in the array. So shape of it is 70. Now let's reshape it to something else. Let's say 35 rows and 2 columns. So okay, let's say 2,35. Easier to see. Okay, so you have 2 rows and 30 columns. So now you want to see what, let's say you do not know this. Let's say you have an unknown array, and only this is shown to you. Only this is shown to you, but nothing else. And you want to know what the shape of this array is to use in your functions, to use for your own purposes. So I say arr3 dot shape. It returns the I'm sorry. Okay. Okay. Right. So you have only this, but nothing else. You want to know the shape of this array. You just type arr3.shape. Shape is an attribute. So the shape is 2,35. That is what you mentioned here before. So yeah. This is what shape is. Shape is used to determine the shape of your array. Okay. Next is okay. Let's say you want to find the data type of the array that you have. Okay, so I'm taking array 3. So I'm gonna type out d type, and then this array has 32-bit integers. So that's what it means. And then okay, there are a lot of other d types, but for now, just determining the data type of it is enough. Okay, so this is what these are the common methods and attributes that you have. Next is indexing and slicing. Every one of you, if you're good at Python, you know that we have indexing and slicing in Python lists, right? The same is here in NumPy arrays. So okay. So I have, let's say, I have an array, ARR. Let's say I have 10 elements in it from 0 to 11. Sorry, it's A range, not range. Okay. And this is my array. I have 11 elements. So I want to get, okay, let's say I need only 0 to 5 and not 6, 7, 8, 9, and 10. So for this, I use array, the variable name, and I pass in the square brackets. And from 0 to you need until 5, right? So the indexing of this array starts from 0. So if I pass in 5, I'll get only 4 because this last is not exclusive. So if I want from 0 to 5, I have to pass in 0 to 6. Sorry. So 0 to 6, you get 0, 1, 2, 3, 4, and 5. If I want from let's say I want from 3, okay, 3 to 7, I only want these 5 numbers. So what I do is I start from 3 and I go on until 8, and then I get these values. 8 because 8 won't be included, it will stop at 7. So this is indexing, slicing, almost the same. Okay, so one important method that you have in array is in NumPy arrays is copying of these arrays. So I'm going to create another variable called array underscore copy, and I'm going to copy the elements of this array onto array underscore copy. So for that, I have this method called arr.copy. And now when I check what array copy has, it has the same elements as array. So this list is this array is copied onto this newly created array. Array. So now I want to convert all of these. Let's say you are given a task and you have to convert. You have to okay, you do not want 1, 2, 3, 0, 1, 2, and 3. You want another thing to be displayed instead of 1, 2, 0, 1, 2, and 3. So what I do for that is, but you do not want to disturb this other array. So I use the copied array that I created, and I say array copy. So I need from 0 to 4, right? I'm gonna initialize it to I'll say new value. Okay, yeah. Oh, okay. You cannot do this because array is homogeneous. So yeah, let's say 100. So sorry. So now when you check array underscore copy, you will have 100, 100, 100, 100, and then you have the rest of the values as it is. This is because from 0 to 4, you have initialized. So these are replaced. 0, 1, 2, and 3 are replaced by 100. So now if you check this previous originally created array will have the same elements. These won't be reflected onto this array because this is a separate array on its own. So that's that. That is this is normal. You know how to do stuff like this. This is a very basic command, but very useful. So next we have okay, let's talk about slicing and indexing in 2D arrays. I'm going to create another array. I'll say array 2D, and I'm going to initialize it to okay. This is my 2D NumPy array. Now, let's say I want to display this. Now I want to access only this row. So what this indexing starts from this is 0. This has index 0. This has index 1, and this has index 2. Now I only want to access the second row, which has the index 1. So I just type array 2D 1. So I this will be returned. This is how you access rows and stuff in a 2D array. But let's say you want to let's say you want to access only 7. You need the value only 7 here. So what you do is pass in the row number first. This row is row number 2, and the number 7 has an index of 0. So array 2D 20 gives you 7. If I want to access 9, let's say, so I say array underscore 2D. This is in the second row, and at the end, right? So I say 2. I get 9. Now let's say you want these values 2 and 3 and 5 and 6. Let's say you want these two values from the first row and 5 and 6 from the second row. How can you do that? Same method will apply, but just a little it's just a little different. So when you look at this is at the end, right? So okay, fine. So I will say from 0 to 2 you display, I'm sorry, from 1 to 3 you want, okay, I'll just display this. So from the in the first row you have 2 and 3, right? You want 2 and 3 to be displayed. So I will pass in 0. Just a second. Awesome. So okay, fine. I want to display 2, 3, and 5, 6, correct? So what I can do is from the first row until 2, and then from the second row from 1. So this displays 2, 3, 5, 6. This might take a little time for you to understand, but as you practice, it will get easier. Now let's say I only want to display 7, 8, 9. It's simple, you know. So I'm just gonna. Another way of you can just say 2. You get this, but another way of doing it is this 2 and all of the elements in 2. So this is how you can. This is another way of accessing rows and columns. So this is it in indexing and slicing. Now I'm sure you all know about relational operators. So relational or logical operators or anything. So let's say you want you have an array. I'm gonna take. Okay, I'll create another one. From 1 to 10, I want integers from 1 to 11, 11 excluded. So I will have from 1 to 10 integers. So now I want to, I only want in my array integers that are greater than 5. Okay, so this returns Boolean values, true or false. 1 is greater than 5, that is false. So false is displayed. 2 is greater than 5, false. 3 false. 4 false. 5 also false. 6, 7, 8, 9, and 10, they're greater than 5. So it's displayed true. So you can even store this in another array, ARR, let's say 1. And then when I display this one, ARR 1, I get this. So you can also, not only this, you can also multiply the array elements present in an array with any integer that you want, and all of the elements present in this array will be multiplied by 2. 1 into 2, 2, and 10 into 2. So this is it. Okay, not only multiplication, addition is also possible. Addition with the same array, you get the same values as multiplication with 2, because ARR plus ARR gives the same. It's like adding the same elements, right? And multiplying the same elements by 2 will result in the same thing. Now, let's say you want to divide all Hello. Okay, cool. I was saying, let's say you want to divide the elements in the first array with the elements in the same array. I will say ARR divided by ARR, and then I get 1 because 1 by 1 is 1, 2 by 2 is 1. So, yeah. Now, these are arithmetic operations. You can also do, you can also take powers, exponents. So, 1 raised to the power of 3 gives 1, 2 to the power 3 gives 8, 3 to the power 3 gives 27, so stuff like that. And there are other mathematical methods that you have. Basic ones are np.sqrt, and you pass in the array. So this returns an array which has a square roots of all the elements that are present in this array. So you can assign it to another array and then perform your functions on it if you want. So this is how you do it. Then there's another function method called exponential. It's abbreviated as exp, and pass in your array. You get e power 1, e power 2. No, sorry. Stuff like that. And then same instead of okay, let's say you have trigonometric functions. Let's say you want to perform trigonometric functions on your array. So I have np dot, this is a function. So np dot sine of all the elements in array. So I get sine of 1, sine 2, sine 3, 0, 1, 2, and 3 and stuff. We also have logarithms, np dot log ARR, and yep. And then you also have the function sum. So let's say you want to this is your array, right? Let's say you want to display the sum of all the elements in your array. So you use this dot sum, and sum of all the elements from 1 to 10 is 55. This can also be applied in matrices. We created a matrix mat1 before, so I'm going to use it on the same mat1.sum. Let's say I want to know the sum of the first row, so I say access equal to 0. Okay, not first, but for all the rows, it'll display the sum. Okay, sorry. Okay, so matrix, this mat1 was not an array before. I converted it to an array. And yes, okay. So to know the sum of all the elements in each row, you do access 0 and access 1 for all the elements, for the sum of all the elements in each row. Access equal to 1. So yeah, this is it. Then you also have, okay, in this is a function that you use extensively in probability and statistics. It's called standard deviation. All of you know about it. So you have a method for a function for, you have a method for calculating the standard deviation of all the elements in an array. It's called STD. So these are the methods and functions that I have for you today. These are very, very basic stuff. More complicated and more advanced operations and functions that you have in NumPy, I will send a link to you right now. You can check it out. And okay, it's a Kaggle link. So yeah, this is it. And the same notebook that I used today, everything including the description is here. So this is what I have for you today. And we have a quiz in a few minutes. If you have any questions, please post them in the chat. Nanda will be taking care of it. And yes, okay. So quiz, if you're ready, I'll begin. The last two commands, yes. 1 second. Yes, STD means standard deviation of the matrix. Correct. No, heterogeneous collections are not possible in NumPy. You can only have one data type. Okay, Nanda, do you want to get started with the quiz?
Yeah, give me just a second.
Yeah. Okay. Okay, so I've sent the Kahoot quiz link in the chat. So whenever you're ready, we can begin. And this is the game pin if you want. Okay, so I'm beginning the quiz now. You can still join if you want, but yeah. So the questions will be displayed here, and you can answer on your devices. First question is, which method do you use to copy one array onto another? The answer is np.copy, as we discussed. You can view the leaderboard here. So let's move on to the next question. How many values does np.random.rand return by default? The questions are based on what we've discussed in the demo session. So you will know the answers to everything in the result. The answer is 1. There's only one value returned by default. This is the leaderboard, top 5 people: Harshita, Ravi, Sri Krishna, Venkat Swaraj, and Shrideep. Next question: to create an array with evenly spaced integers in a given range, which method would you use? The answer is linspace, as we've discussed. Next question is, how would you reshape a 1D array of size 10 into a 2D array of 5 rows and 2 columns? Okay, so I feel like I have to give an explanation here because for reshape, you always pass the size of the array in a tuple. You don't just pass 5 comma 2, you pass it in a tuple in parenthesis 5 comma 2, and only then will this work. So yeah. Awesome. So next question, we have 10 questions. Which of the following options generates this output? This output that's given here. 1, 5.5, 10. Awesome. So a lot of you gave this 1, 5, and 2. It's not right because you have 3 values here, 1, 5.5, and 10. That is 3. So looking at the last value here, you can tell that this is not the right option. 1, 10, and 3, because linspace, it creates an array of equally spaced integers, right? Evenly spaced integers. So 1, 5.5, and 10, they are evenly spaced between 1 and 10, and they're 3 in number. So this is the right option. Awesome. So cool. Next question. This is the 6th one. Determine what output the following piece of code generates. This is the code. Okay, so the difference between option 2 and option 4 is that when you see there are only 2 square brackets and there is 1 comma here, but when you see, okay, this creates 2 columns and 2 rows and 1 column, correct? So 6 is in the first row and 9 is in the second row. So that is the difference. So this is only a single row. These are 2 different rows. So this is a tricky question. Whoever got it right, awesome. Cool. We have next question. What does NumPy stand for? NumPy is numerical Python. So, yep. Next question is true or false. NumPy arrays are slower than Python lists. This question has 10 seconds, so answer fast. Awesome. NumPy arrays are not slower than Python lists. They're very compact and more efficient than Python lists. What is the correct syntax to use arrange? Awesome. The correct syntax of arrange is start, stop, and step. This is the last question. What does random mean? So random means something that cannot be predicted logically, as I mentioned. It's not different result every time you execute. It is different result every time you execute, but that is not the correct answer. That is not the correct explanation. Different result for each user is also correct, but that is not the logical explanation to it. So something that cannot be predicted logically is correct. So Venkateswaraj has the third place and Ravi has the second place and Harshita has the first place. Congratulations, you get certificate of appreciation from our side. So runner-up are Kadir and sorry, I missed the name. Awesome. So this marks the end of the workshop. So I hope you had fun and I hope you learned a lot. We will be talking about pandas tomorrow, same timing, and we'll be sharing the links soon. So thank you for joining. If you have any questions, please put them in the chat. We'll answer.
Hi everyone. So the Google Form link is in the bio. Please fill your details and your work, and also share us your feedback. And thank you all for joining us today. And don't forget to join the Discord channel for more communication and discussion related to data analysis. Thank you all.
So there's a question. Are NumPy arrays stored at only one place in memory? Yes, NumPy arrays are stored in contiguous memory locations. So yes, they're stored at one place together. Okay, so np.zeros float 64 because okay, let me tell you. Hang on. Okay, so can you see my screen? Oh, I'm sorry. Just a second. Can you see my screen?
Not yet.
Okay. Can you see my screen now? Okay, cool. Awesome. So the question was, why do we get D type as int 32 but not float 64? Because the method zeros and ones, they expect an integer by default. But can you see my screen? I'm sorry. Okay, cool. So as I was saying, zeros and ones, they expect an integer by default. The reason you get this is because, okay, so how do I explain? So int 32 is what it expects on its own, but we get float 64. These are floating point values, as you can see. 0 dot is a floating point value. Since it expects in 32, you get when you say d type 32, when you call d type, I cannot find it here, I'm sorry, but when you give the attribute d type, you get int 32 because by default it returns an integer value, but the representation of it is in float. So if you go through the links that I sent, you will find the explanation to it in a much better way. This is not the correct proper explanation. So yeah, just go through the links that I sent. So this is it. If you do not have any other questions, then you can leave the session. Thank you for joining, and have a good day.
I'd like to add something. We'll be giving certificate of participation for people who attend both the sessions. So kindly please fill the feedback form so that we know you've attended the session today. Thank you.